Hi, I'm Mr. eTutor, your mystery tutor here at mysterytutor.com, and welcome to video module 6-10. In the previous module, we discussed one standard that you're likely to find in the answer choices of a real SAT math question. And in this module, we'll be discussing a second standard. Now, this standard appears less often than the standard we discussed in the earlier module, but when it does appear, it's far more likely to indicate a correct answer choice. This standard is called the grouping standard, and it works like this. Whenever you have an SAT math question whose answer choices are a series of algebraic expressions with very minor differences from one expression to the next, you can apply the grouping standard. This will usually only be on 2 questions per section. Before we get into what the grouping standard actually is, let's take a moment to put ourselves in the College Board's place again. Remember, we always want to look at the SAT from the perspective of the people who designed the SAT, because that will tell us an awful lot about what we should be considering in order to beat the test. As we discussed in an earlier module, the College Board has decided on a multiple choice format for most questions on the SAT. This is probably for reasons of objectivity and convenience. As we also discussed, an unfortunate drawback of multiple choice from the College Board's perspective is that multiple choice requires us to put the correct answer to every single question in front of every single test taker. Obviously, if you're the company designing the test, you can't be too thrilled about that. So, when the College Board wants to create an SAT math question that requires an algebraic expression for an answer choice, they're in an especially tough spot. Here's why. If you put a list of algebraic expressions in the answer choices, most students will realize they can simply back solve from the answer choices to find an answer that works for the question. So in these special cases, the College Board goes out of its way to make the incorrect algebraic expressions look especially tempting to a test taker. As you can see, in those situations, the College Board often generates a list of incorrect answer choices that look extremely similar to the correct answer choice. Now, think about this from the College Board's perspective. If your goal is to create 4 incorrect answer choices that stand a good chance of distracting the test taker from the correct answer choice, then you want those incorrect answer choices to look as much like the correct answer choice as possible. That makes sense, doesn't it? But now let's look at it from another angle. As the test takers, if we know the College Board is probably trying to do this with a list of answer choices like this one, then we can reverse engineer the process to our benefit. If you think about it, doesn't it kind of make sense that the answer choice that has the most in common with the greatest number of other answer choices is probably the correct answer choice? This should probably be the case because most of the wrong answer choices are trying to imitate the correct answer choice. So again, the answer choice that contains the most popular features from all the answer choices is probably the correct answer. Once we recognize that, we can apply the grouping standard with stunning accuracy. To apply the grouping standard, you want to look at the list of answer choices and figure out what separates each answer choice from the other answer choices. In this particular set of answer choices, each answer choice includes one x term, a plus sign, one y term, a plus or minus sign, and then a k term. That makes sense, right? That's pretty easy to see. Now, what we're going to do is break all of these answer choices down into their specific components. So, for example, we'll consider the x term as one component. We'll consider the y term as one component. We'll consider the plus or minus as another component, and we'll consider the k term as a separate component as well. To figure out whether the correct answer choice probably involves x or 2x, we simply count how many x's are there versus how many 2x's. Well, here we've got 4 answer choices that involve x and 1 answer choice that involves 2x. So probably the correct answer choice will involve 1x. Every single answer choice involves a plus sign for the next thing, so the correct answer choice will certainly involve a plus sign. Now, as to whether the correct answer choice involves a y or 2y, it's the same thing as we did for x. There are 4 y's and 1 2y. So probably the correct answer choice involves y. Now things get a little bit trickier maybe. If we're trying to decide whether the next sign should be a plus sign or a minus sign, we take the same vote. Sure enough, there are 3 minus signs and only 2 plus signs, so probably the next sign is a minus sign. Finally, as to whether the k term should be a simple k or 2k, we notice that 3 answer choices have 2k and only 2 answer choices have k. So probably the correct answer choice involves 2k. Now, according to the grouping standard, it looks like x plus y minus 2k should be the correct answer choice. And sure enough, it is. The question that these answer choices were taken from appears on page 427, number 16. By the way, right there on the same page, number 13 provides answer choices that are equally susceptible to this standard. You may be surprised how easy this is to apply, and you may be surprised how often it works. This standard is far more likely to generate correct answer choices than it is incorrect answer choices, so feel free to use it often. By the way, I want to make something clear. When you apply these standards, I never recommend that they be the only basis for your answer selection. Instead, I recommend that you use them to check your work or suggest a way to begin a problem that seems especially challenging. So, for example, if we were looking at question 16 on page 427 and we weren't sure how to begin looking for the answer, we might notice that we could apply the grouping standard and start from there. After we realize that the grouping standard seems to be indicating that x plus y minus 2k is the correct answer, then we want to ask ourselves, okay, I know the grouping standard is fairly reliable, and I know it's pointing at this answer choice. Why is this answer choice correct? If we can work out a reason for this answer choice to be correct, and we're certain we haven't made any mistakes, then we go ahead and mark it. And in that instance, the grouping standard is used not to determine the answer conclusively, but to give us a jumping off point so we can work the answer out on our own. As a general rule, you do not want to rely on patterns exclusively. Always make sure you can back up what a pattern points to with basic math concepts. I want to say that one more time just to be totally clear. Don't use the standards by themselves. Always back the standards up with basic math concepts. If you can explain an answer choice to you and the standard also points to the answer choice, then you're doubly certain that you're correct. Similarly, if a standard happens to point to a different answer choice, but after thinking about it really hard, you're sure that your answer choice is correct, go with what you think is mathematically correct, not with what the standard indicates. Among other things, you might have accidentally applied the standard incorrectly. So that's it for the grouping standard, the second standard in our answer choices. Enjoy the rest of the modules, keep an open mind, and remember, it's easier than you think.